Hello and welcome everyone. We are excited to have you join us today for what's said to be an insightful session. It's a pleasure to bring you this webinar and we are glad to feature Saurabh, one of our finest engineers. He's been on the team for an extended period of time. Also, we encourage your interaction. So if you have any questions, don't hold back. Drop them in the Zoom chat anytime and we'll address them during the QA segment. So let's jump right in. I'm now passing it over to Saurabh, who will get us started. Hi, Saurabh.
Uh, Thank you, Dipto. Good afternoon, folks. I am Saurabh Chandra Vishwas, currently serving as Senior Software Engineer at Abscora INC. So I am here to demonstrate how you can basically run Oracle databases using KubeDB operator. So without any delay, I think we will start from here. So throughout this session, I will be going few of the contents that I am showing you. So first, I will kind of demonstrate you what is basically Oracle database. I hope most of you already knew about it. So, and what KubeDB offers for Oracle database, and then how you can basically provision Oracle databases using our KubeDB operator. And then I will just show you a live demo uh, where you will see me doing it. Okay. And later we will have a short question and answer session. So here are few things about Oracle database. I think most of you already knew about it. So basically, Oracle is a relational database model where it is currently leading the database market. If you search it on Google, you will find that in most of the DB engine, it is currently being ranked number one. And it also supports PL/SQL like extension I think you have heard of it if you have used Postgres any time of your career. Also, it by default supports acid compilance. uh, Give me a second. Sorry for the interruption. Okay, so I will just quickly move around these things. So what we are bringing here for now is you can simplify the provisioning of Oracle database using our Kubernetes operator. And there we currently continuously run a health checker that you can very much configure as you like. And what this health checker basically do is it kind of just continuously ping your database and check if we can read from the database and write into it. So if any moment of your database lifecycle management, uh, yeah, we cannot write or read in the data, then we will kind of let you know that we're not being able to uh, do any write or read in the database. So we also provide secure authentication using Kubernetes secrets. Also, we have built-in support for high availability where the failover will be automatic. Like uh, in a scenario, you can imagine that your database pod, which was primary previously, goes down. So another pod, which was running as replica, will be promoted as primary. So at any moment, your database will be available. Maybe there might be some RTO, but that is relatively smaller. So we are currently supporting only Enterprise Edition and a particular version of it. However, we are planning to extend it in future release. Okay. So we also have multiple deletion policies that I will describe in later slides. And as you know, as as it is a database, so the data need to be persisted, right? So we are using persistent volume for that, obviously. Um, so from your perspective, you will just need to create a custom resource, okay, a Oracle custom resource, and then our provisioner operator is watching that particular custom resource and it will create the necessary environment to run your database um, in Kubernetes. So what are those resources? You can see here we are creating a stateful set and persistent volume claims, app binding, services, secrets are back. There are a bunch of these, different resources that we are creating. So as a user, I think you do not need to worry about them because we are managing all of these using this particular provisioner operator. Okay, so from your perspective, you can just create this resource and we will manage all the lifecycle flow of Oracle custom resource. Now, in my previous slide, if you remember, I talked about delegation policies. So, previously this was known as termination policy. So, what this is basically, suppose in a moment of life cycle of Oracle, you decided that you will terminate that particular Oracle instance. So, based on the policy that you will mention in this particular CR, we will delete the resources that we created in the previous slide. You see we created this type of resources. So based on your selected termination policy, we will delete the databases differently. So if you mention database deletion policy wipeout, then whatsoever will not keep any trace of your database. None of the resources that we created, we are going to store it. But if you provide it to do not terminate, which is you will definitely not want to your database get deleted by some unnecessary or maybe unconscious maybe you just somehow mistakenly run a command that would delete your database instance. So you will not definitely want that in production grade environment. So for production grade environment, what you will do, the termination policy do not terminate, and in the backend what we will do, we will use a validation overview configuration to reject your deletion delete call, right? So and then there is halt. So what this means is if you delete your database, we will delete all the particular resources except the secrets and persistent volumes. Okay, so what are the use case for this? Suppose for any reason you want to delete your custom resource for the database that you have created, but you want to persist the data so that you can later come back and get the same resource again with the existing database data, I mean PVC. Okay, and also the same credentials. So this can be done if you just set the deletion policy to halt, and this particular deletion policy, that is delete, this will only keep the secret. And if you have enabled backup, it will also store another component called snapshot. I'm not going over that because I haven't implemented the backup part. So if you want to just keep the database secret, that means database password, username, then you can mention deletion policy as delete. So what it will do, it will just keep the secrets and delete all the other components. Okay, so super, so good. Now I have only implemented this so far, so nothing more on this side. Now this is the command that you typically use for installing KubeDB, and be sure that you are mentioning this flag set global.featureget.oracle equal to. Why we need to set this flag? Because by default this is set to false. So if you just install the KubeDB without mentioning this flag, then you won't be able to use the Oracle database. So be sure that you are using this and you are kind of setting the correct path for license of txt. Okay, so this is basically a sample YAML for Oracle version. Currently we have only added support for Oracle 21.3.0. Okay, so basically we kind of encourage you to use your own image, your own database image. However, we are giving a image for you to test it, but in your production you will want to use your own image. And how you can build your own image, this is kind of demonstrated in this particular link. I will just give you a brief overview on this, but for now you just remember that you will need to change this particular db image. Okay, so other things you can just keep it as it is. So for now we are supporting only standalone mode and dataguard clustering mode. If you are familiar with Oracle, then you know that Oracle supports many other features, many other replication strategies, but for now and for brevity we are only supporting these two particular mode, which is standalone and clustering. Okay, so standalone, this is pretty much it. You can just mention this YAML and apply it, and whole production great database, Oracle database will be ready for you. So we will after some time we'll just go and apply this YAML. You will see it that this will kind of provision a database, and we will run some queries on that database. And this is somewhat a little bit bigger, you might think that it appears. So it has few stuff fields. If you just notice, you see that. So I will just go over this quickly, and maybe while I am demonstrating I will try to give you a more expanded look on this. So you see there is a data guard field, which is the Oracle component called data guard for guarding your data, basically, so that they are not lost. Okay, so I'm skipping this part because I will be demonstrating you, and will try to explain as much field as I can. So yeah, I think that's it for now, and now let's just jump in with the demo part. Um, you know, running Oracle in Kubernetes, I think is relatively tough than running Postgres or any other databases, because if I just show you provisioning, if I just provision a Postgres database here, I think it will be ready within a minute, less than a minute. A Postgres database will be up and running, but that's not the case for Oracle. uh, you know a Oracle database image, let me just show you something maybe. Oracle. Okay, so basically this image is really huge. This is their official image, and this image, I think, as far as I remember, it has 8 GB of size. You know, so it really takes a lot of time to boost up the database. Maybe uh, 10 minutes, 10 minutes at least for per port. Okay, so if if I just show you a database provisioning, then it would take at least 20 minutes of your research time. So what I have done is I have pre-provisioned a database beforehand. So I just show you the YAML. Okay, so let's just go. Let's just save it in a file and then open it using VS Code so that I can explain it to you a bit more easily. Yeah. So I think you know about this file, right? If you are familiar with KubeDB. So this is the main field that I'll be focusing on for clustering part. So these are the fields. If you just kind of Google it, then you will find it very easily. This is basically data card properties. And what does that mean is how much lag I am letting the data guard to apply the logs. Okay, so yeah, so you can just go here and read about this type of fields. So I am not going to detail in detail this particular fields. That would take so much time. I will just go over quite a few that is important in my sense. Yeah, so protection mode, you can basically select three protection mode, and I have selected maximum protection, which means that Oracle Data Guard Oracle Data Guard will try to you know give you maximum protection while it is transporting the data over the wire. I mean, suppose a primary is trying to send is committed entries to standby, then it will try to give you the maximum protection in this layer. And the data synchronization between primary and standby is kind of synchronous. You can set it to async, but for now I have to set it to sync. Okay, and this is the deletion policy that termination policy. Basically, it was previously known as termination policy, but for now it is known as deletion policy, and I have set it to delete. Okay, and the edition is enterprise. So this type of thing you really do not need to mention. You can just apply the YAML that I showed you here. Yeah, this one basically you can just apply it. And the other thing that you are seeing here is basically defaulted by our operator. Okay, so if you apply this YAML, then you will have a scenario like this, where you will have as I have mentioned, three replicas. You can see here, if I just show you the replicas part. Yeah, you see three replicas. So we have 1, 2, and 3 replicas, and there is another pod which is observer. This is basically a Oracle observer observing these three databases. So what is the job of this observer? Uh, it basically watches for any drift in the failover, I mean leader. So for now, if I just show you the role, yeah, you see Oracle sample 0 is currently running as primary. Okay, so if somehow this Oracle sample 0 disappear, let's just say it disappeared from the cluster. So that means you have lost your right replica. I mean, basically, which was in the only mean to write in our cluster, database cluster. So this will be noticed by this particular pod, and then what it will do, it will initiate the failover process, and it will eventually make any of the available replicas as primary. Okay, so this is basically the job of this observer. If you want to read more about it, you can just search Oracle Observer, and you will find tons of resources based on this observer thing. Okay, so let's just see if the data is being replicated. I am signing as root user. So I have created a table already, and I have inserted some data there. You see, there are a few data that have already inserted. So let's insert some other data. Let's say 9. Okay. Now let's just verify. Of select all from hello. Pardon me. Yeah, so the data is here. Now we will need to make a commit, because as long as I'm not committing, okay, as long as I'm not committing, Oracle will not send that data to its followers. That means its replicas. So I'll need to do this commit. And now if I execute into the any of the replica pod, then I should be able to see the data. SQL plus the same command I'm using here. SQL plus this. Why I am typing so wrong? Okay. From hello. Yeah, you see that this data is now available in the standby. Okay. So now let's just try to similar some failover scenarios, but I warn you that this is going to take some time. I mean, failover in Oracle is really a process where it's typically a scenario where you really lost your primary. That means it might just run away from your whole infrastructure system because Oracle, insist you not to do failover unless it's utterly necessary. Like for Postgres, if I just, I think let's just show you deploying a Postgres. Mm, I think this is okay. Let's just show it. Just see how long it takes. Okay, so the main purpose of showing you a Postgres instance inside Oracle database is uh, if we try to do a failover using a Postgres instance, you will see the failover will be very instantaneous. That means the failover will happen just by the click of your eyes, I think. But this is not the case for Oracle because in Oracle, you are basically instructed to do a failover only when it's needed. So because for failover, Oracle need to do a lot of thing that takes time. Obviously, maybe it can take up to 1 minute. Okay, so our observer pod will try to you know make the pod that we will kind of trying to delete primary again. If it really cannot make it, then it will do a failover. Okay, so I think my Postgres should be ready. Yeah, it's ready. And if I just run the same command, shin- no, I think let's just okay. So yeah, you see, AC Postgres on is set as primary. So if I just delete this port, you can expect a failover real quick. So let's just see. Yeah, you see the reciprocal zero has been already decided as primary, but this won't be the case for Oracle. That's all the perspective that I wanted to show you a Postgres instance here. So I'm just deleting the Postgres instance and let me get back with the Oracle. So you see which one is the primary? I think Oracle 0 is the primary. Yeah, Oracle 0 is the primary. No, I think it's Oracle sample on, which is the primary. Let's just yeah, Oracle sample 0 is primary. So let's just try to simulate a failover scenario. You know, let's see. Okay. So no, so sometimes it will do a failover and sometimes it will not do a failover because if this pod is back, then this particular observer will not do a failover because it will see that previous primary is back. Okay. So this thing can be, however, this thing can be controlled. Okay, using our API. I will show that also. But for now, let's see if that failover happens. Okay. So it has lost the role, and let's see if some other pod get the primary role. Okay, you see our database has moved from ready to not ready, and not ready means basically there is no primary in the cluster currently. Give me a second. Yeah, you see the failover happens. Now Oracle sample on is primary, and and if I show you the log from observer, you see this cluster will take some time to back in the ready state again, because the primary that we lost earlier need to be reinstated. That is a term from Oracle, where they need to do bunch of stuff on the previous failed primary, and then regenerate the logs and all these stuffs, and then it will be able to join the cluster once again. So this will basically take some time, maybe up to 5 minutes it might take. So yeah, I think, yeah, you see reinstated database Oracle sample 0. So this is something that is Oracle doing in the background, and it will take some time. So let's just wait. In the meantime, we can exit into the primary pod and see if we can do in some insert query here. SQL plus. Yeah, successfully reinstated. So yeah, now this will be in ready. Yeah, you see now this is in ready state. So now let's verify if we can do some insert query here. You see this is the new primary, right? Previous primary was Oracle sample 0. Okay. Now, yeah, you see we have created here. That means this is the primary. Now let's just show you the column. You see, chain is available here. Now let's verify it from our failed primary, whether he has joined in our cluster. Select from, yeah, you see that we have got it. So the failure was successful, right? Now I think this is all for clustering part. I will show you now standalone. Let's just delete this current Oracle. I don't want to create so much load on the cluster. Yeah, let's just wait for it. So Oracle standalone. Yeah. So we're going to deploy this. For standalone, we will have to mention the replicas on, and the mode should be standalone. Okay. So standalone means basically there is no clustering going on here. Only a single instance is there. Okay. So let's just create this particular YAML. Oracle standalone. Yeah, you see the spot is coming up. This will take, up to 10 minutes. So I think we will have to wait this 10 minutes. And in the meantime, I'll show you the log from the spot. Yeah, you see, it's something that is Oracle doing in the background. So it is trying to create the database, which is roughly maybe 500 seconds, or yeah, around that. Okay. One thing that I want to discuss here is, for running a Oracle instance, you need to provide a bare minimum of 3 gigs of RAM and a CPU as low as 2, or yeah, 1 will also do it, but I'll suggest to put it at least 2, and request you can just put as you like. And for coordinator, this is basically the container that we use for managing the clustering thing. Okay, and for that you can keep the resource as low as it's given here. Maybe you can also reduce it if you want. And yeah, so I think this is quite it. Yeah. Okay, so let's just wait until the database execution completed. It's 36% done. Okay, so meanwhile, if you guys have any question, you can ask me while the database is being provisioned. I might try to answer your question if you have any. Well, while we are sitting, I think I can show you how you will build the Oracle image. So you just go on the Google and the search for Oracle Docker GitHub. Okay, you should find this particular repository. So from there, just enter inside it and find Oracle database. Okay, and then find the single instance. Okay, so basically what you will do, you will typically copy this repository, clone this repository inside your local local directory, like as I have done here. If I just show you, yeah, going on. Yeah. So this is the repository. Okay, whatever you are, whatever you are seeing here, is the same. Okay, so for building your own Docker image, you will need to first download the DB binary. Okay, from online you can just search Oracle 20 on Enterprise Edition download. Okay, Enterprise Edition download. I think I'll have to mention the Linux part. Yeah, you'll see there are bunch of extension RPM and zip. You will typically install the zip. Okay, you will just click here, and from here you will download it, and then you will put it in this folder. You carefully look where the folder associated it is inside Oracle database, and then you will go inside single instance, and there and inside single instance you'll find Docker file. Okay, and then inside your particular version you will put the file like this. You see that I have already installed it and put it here. So as you have it here, and then what you will do, you will kind of run this single command. You see that you will run this binary this shell script that is here, build container traces, and you will provide the version using -v flag, and then you will give it a tag, whatever tag you want to give it, and dash image basically say enterprise edition image. Okay, so I will show you again the directory where you need to put the download binary is under Docker images, Oracle database, single instance, and then under Docker files you will see a bunch of versions. From there you will choose your appropriate version, and inside there you will just kind of put the image, put the downloaded binaries. So all these instance you can find in here. If you just fit this particular log, you'll see what you basically need to do to build your own image. So once your image build is done, then what you can do, you can just copy your image, and then you can just say kubectl edit, then Oracle version and your Oracle version name, and then you will just search for the image. I think yeah, I think above one. So you will just come here and just paste your own image. Okay, so this should be good for you. I'm not saving it. So now let's see if, yeah, I think database build has been done and our database should be in ready state. Yeah, you see it's in ready state. So now let's just try to do some queries in our database. So SQL plus root and sysdba. So let's just create a table first. Create table hello id int, and then just hit enter. So now what we do, insert into hello id values on. Okay, see we now have a single instance. So one question is how you are you know going to use this particular database. Station demo. You see, this is the service that you will basically use. Okay, for your client facing application you will provide this particular service, and you can pretty much do whatever I am doing here, I mean inside your single instance. Okay, so I think that's all from this particular webinar, and I will respectfully ask your question if you have any, and yeah, you can put your questions in the chat, or you can just directly ask if you have any questions. Thank you.
So yeah, that wraps up our today's webinar. Thank you, Saurabh, for this insightful webinar with hands-on demo.
Thank you, Deep,
Um,
also.
yeah, a big thanks to each of you for being here and contributing to the session. We are excited to continue the conversation in our upcoming events. Be sure to check out appscode.com/webinar to explore our full webinar lineup and secure your spot. Until next time, take care and have a great day. Bye bye.